I'm back with the jar after dumping it out, and I really should have rinsed the jar out with distilled water. Instead, I just dumped out the contents, the previous contents, in the sink. Of course, I don't know what the contents were before, and if I were doing this change properly, I should be rinsing the jar out with distilled water and then making sure it was completely dry before I added new contents. Because after all, if the simulator had been used for some substance other than ethanol, or a mix of ethanol and something else, I would be distorting what I'm trying to accomplish by having a simulator. I'll take my bottle of 100 solution. In this particular case, the label says that it's CalWave. And I will break open the seal on it. There is an outer seal on the cap that I will open up. Take the cap off, and there is an inner seal on the top of the bottle. I'll break that open. I suppose I should be careful about what's on the pair of scissors or other sharp object that I'm using. If it's a key or a knife, there's nothing else on it. I will dump the contents of the 500 ml bottle into the jar. Now, this particular simulator that I'm changing, it's cold. All of the mechanical workings of the simulator are cold. If the simulator was hot and I was doing this, the danger that would be that I might damage the inside workings of the simulator. There are a lot of very, very sensitive pieces of mechanical apparatus in the simulator that could be damaged if they're hot and they're taken out of the hot water or ethanol mix that's in the simulator when you're changing it. So this one, I made sure that it had cooled down. So I'm going to put it back together again. Carefully again, because I don't want the glass to crack. And this one has already cracked. I don't want it to crack anymore. And you know, it really isn't a very good seal. It's not going right down to the rubber gasket. And potentially that's a problem, because I'm relying upon this being a secure seal between the headspace at the top of the simulator and the housing of the simulator. Otherwise, there's no point in using this simulator. It's not going to be a very good piece of lab equipment if there's no good seal. And unfortunately, this one is well worn. You'll notice that the particular thermometer that's in this simulator is a red alcohol thermometer. I'll try and zoom up on it a bit so you can see it better. And you'll see that the individual markings on the temperature, you can see it's at room temperature, about 21 degrees Celsius. And you can see that the individual markings on this particular thermometer are in units of 1 degree Celsius. For purposes of using simulators with approved instruments and with the calibration of screening devices in Canada, we need to use a better thermometer than this. We should not be using an alcohol thermometer. We need to be using a thermometer that is a mercury thermometer. It should be a NIST approved thermometer, and it should also be a thermometer that allows us to be able to tell whether the temperature is in fact 34.0 degrees Celsius plus or minus 0.2 degrees Celsius. So I'm going to change this thermometer, first of all, to another mercury thermometer. And you can see that many different kinds of thermometers will fit into this simulator. It's always struck me that if a police officer didn't have the correct NIST thermometer, it would be awfully easy for them to obtain from a scientific shop a mercury thermometer just like the one that I've put in, and be able to say in court what the temperature was of the simulator, even though it wasn't the proper NIST thermometer. Now I'm going to zoom up on this one. This is not the proper thermometer, it's a mercury thermometer. And you can see that what you can see of the mercury is very sensitive to the light in the room. I'm in a room with some sunlight streaming in and some slats in the window that are opening and closing a little bit, and just depending on how you look at it, sometimes you can see the mercury, sometimes you can't. These mercury thermometers are often fairly difficult to be able to read. So again, this is a thermometer at room temperature at about 21 degrees Celsius, and again, its units are in units of 1 degree Celsius. The markings on it are showing 20 degrees Celsius and 30 degrees Celsius, and each individual marking is a unit of 1. So that's 21 degrees Celsius for that particular thermometer. The proper thermometer that the police should be using is one of these. It's a mercury thermometer that has markings on it that center at 34.0 degrees Celsius and go down as low as 33.5 and go up to 34.5 degrees with markings on it so that you can tell the difference between 34.0, 34.1, 34.2, and so on. I'm going to put this thermometer in and then zoom up for a close look. You'll see that this is a much smaller thermometer, and you cannot see the mercury column inside it, and that's because it's down in the bottom of the tube, because the temperature is well below 34 degrees Celsius. But you can see clearly there the marking of 34, 34.5, and 33.5. A police officer needs to be able to make a determination of whether the temperature was within the range of 33.8 to 34.2 degrees Celsius. Because if the thermometer temperature is outside that range, then they're not using the solution at the correct temperature. I'm just going to turn this thermometer a little bit so that you can see the markings on the side. Now you can get a bit more of an appreciation of the markings on either side of 34.0 degrees Celsius. Now you'll notice on my blotter where I've just changed the solution that I've spilled a little bit of ethanol from the alcohol standard, so I'm going to have to clean that up. Made a bit of a mess of my desk here, but it's important that in a breath room that any spills of ethanol or any other substance that might be there in the breath room are cleaned up and the paper is disposed of in a place far away from the Intoxilyzer and far away from any of the other equipment that's going to be used, because if you have ethanol floating around in the air, it's going to change the ambient conditions for the approved instrument or for the screening devices that you are in the process of calibrating.